In figure, DE and OQ are parallel and DF and OR are parallel, 1 and 2. Prove that EF is parallel to QR. We have to prove that. So now my request is pause the video and draw. Draw things which is given, which parallel and things being parallel, those things, whatever in whichever triangles they are in, draw those. So we are looking at first is D being parallel to QO. It's in which triangle? It's in triangle PQO. So let's draw PQO. Right? And the thing which is parallel is ED. Right? So we need to label them as well. P, Q, O, and E and D. Next is which triangle? DF being parallel to OR. That is in triangle. That's in triangle POR. Right? So almost to scale you guys can draw. Or it has to look same. Scale, it's okay. I mean, the size is okay. POR and DF. So this is parallel to this, while this is parallel to this. And yes, we need to prove this, but let's do write it. Say EF is parallel to QR. In which triangle are we looking at? We're looking at triangle PQR. PQR. And the side which is parallel to the third side is EF. Right? We have to prove this two is parallel. So as per our usual schedule, we need to write given. So we have DE is parallel to OQ, DF is parallel to OR, and oh yeah, that is to be proved. We need to prove that EF is parallel to QR. So the next thing we have to do is in triangle PQR, right? No, PQR, not sorry, not PQR, PQO. What is that I'm trying to do? As per the there are three triangles, right? Apply BPT to them. Okay, not the third one, the first two. Just apply. Don't think about what you need as a final answer. We are just writing what is given. That's all, and applying the theorem which we know. So for this, we can apply BPT. So let's apply it. That's all we are doing. As ED is parallel to QO, as per BPT, we can conclude that PE by EQ is equal to PD by DO. Right? We'll call this as equation 1. Next is in triangle POR, as DF is parallel to OR, as per BPT, we can tell that PD by DO, right? PD by DO is equal to PF by FR. All this is quite simple. We're just writing, nothing else. Now, the next step is the conclusion. So from 1 and 2, what can you conclude? It's time to pause and think. So as PE by EQ is equal to PD by DO, and PD by DO is also equal to PF by FR, we can conclude that PE by EQ is equal to PF by FR, right? So that's all. We'll write that PE by EQ is equal to PF by FR. Now let's actually think about the question. We have to show that this is parallel to this. EF is parallel to QR. See, which theorem does help us with this? Converse of BPT. What does converse of BPT tell? Converse of BPT tells that if I have PF PE by EQ being equal to PF by FR, then I can tell these two sides are parallel. These two lines are parallel. Well, we actually have done it, right? We just did that. We just showed that these two sides is equal to ratio of these two parts. So we're pretty much done. See, without thinking about the answer, we got the answer. So that's the good thing about geometry. Most of the geometry question you can attend like this. All you have to do is you have a diagram, segregate the diagram, think about the diagram, think in different ways, apply the theorem, whatever is possible to that particular scenario. And the answer is a link between all of them. In this case, the link was P dy do. That was your negotiator, right? And thus we can conclude that in triangle PQR as per equation 3 and converse of BPT, we can conclude EF is parallel to QR. Hence proved. That's it. So we can pause and have a look at the answer.